Hello class, welcome to Module 11. Last week we started looking at object-oriented programming and some of the basics around that. This week we're going to build on that knowledge and show some other things that you can do with classes and objects and object-oriented programming in general. Topic 1 in this module is actually essentially a review of last week, maybe a few more minor things you can do there, as well as an assignment. You'll just want to start there and read through that topic and see some stuff there. I'm going to go past that one right now because everything should be pretty self-explanatory in Blackboard on that topic. Topic 2 is where we get into something fairly new, and we're going to talk about inheritance. Inheritance of a class is taking on attributes of that class. So everything we did last week was just a class that you could create objects from. Now we're going to create multiple classes and make them interact. And inheritance is one way that they can interact, where you have a parent class and a child class, or you can call it a superclass and a subclass, or you can call it a base class and a derived class. They all essentially mean the same thing. It's just a relationship between the two classes. And when you do inheritance, the child, sub, or derived class can take on attributes of the parent class. So here's just a few examples. If you want to look at it this way, the one on the left is the parent, the one on the right is the child. Every student is a person, but not every person is a student. Every truck is a vehicle, but not every vehicle is a truck. Every community college is a school, but not every school is a community college. So one fits within the other. So the person class is a much larger class, whereas the student class would be a subset of people. So again, we're going to do the UML diagrams like we did last week. This is an example of a UML where you've got the person class, which has name, age, and gender, and some methods, an age group method, and of course our normal str method. Remember, str is how we override the print functionality. Is going to be a parent class to the student class. And the student class has major, and it has GPA, and then it has a method called will graduate someday. And the student class will also inherit attributes from the person class. There's no reason to make the student class include all of these values that could be held within another class. As your projects get more complex, you're going to find that you, especially when you're doing object-oriented, that you will have multiple classes interacting with each other in this way. So here is my person class. My parent class is what I'm establishing here. Just like last week, it's called class. You use person as the name, capital letter at the beginning of a class name. If I have any kind of class attributes, they would go here. I just stuck one in there, so there was one there. And then we do our init method here, where we have the self and the attributes of the class. So I'm putting name, age, and gender, just like we saw in the UML. Self.name equals name, self.age equals age, and self.gender equals gender. And then this is my method for this class. And all it does is, if the age is less than 18, it returns something. If it's less than 40, it returns something. Otherwise, it returns something else. And then I've got that str function, like I mentioned, that can just output information about the class. So that's my parent class. Now, the new thing, well, first I'm going to instantiate a person. You can see my person one, and then I'm going to print some information just so you can see it working. So you can see here's that str. Is because I've established the str. When I go to print my object, it gives me the information that I want. And then I can also use that method, age group. Since I'm 39, age group would be adult, according to the output from that method. Okay, nothing new there. Now we're going to make that derived student class from the person class. When you create a derived class or a child class, to give it the relationship between it and the parent class, you can see here I have class student, and in parentheses, it takes on person. So this is how you create that relationship between your parent and child. The child takes on person. So this is how you create that link. Again, you start with your init method here, where you've got all of the attributes that will be part of the child class. So you can see I've got name, age, and gender, which are going to be inherited from the parent class. And then I'm adding 2 more attributes, major and GPA. And to have them utilize the parent class, you can use super, just like this, super dot underscore underscore init underscore underscore. And then you can say what attributes is taking from that parent class. So I'm taking name, age, and gender. So it's inheriting them from the parent class. And then I'm also, from just this class, using self.major equals major and self.gpa equals GPA. And then I'm adding a method here as well, saying we'll graduate someday. And if the GPA is less than 1, it's not going to happen. Otherwise, less than 2.2, there's a chance. Otherwise, they're going to graduate. And then I have another str on this class. So I'm going to run this to create my class. And then I'm going to instantiate a new student object. Now, you have to, when you instantiate your object, you have to give it all of the attributes. So you can see my student1 equals object type student. And it's got these 3 things, which are name, age, and gender, which were inherited from the parent class, as well as the 2 that are part of the child class, which I have CIS, so major, and GPA. So I'm going to create this object, which I've now done. And now I can utilize methods in my derived class. So I'm going to use my str first of all. I'm going to use my will graduate someday method. Now I have a 4.0 GPA, so you know that's going to return that I'm going to graduate because I have a high enough GPA. So I am, just like you would with a normal class, a normal object utilizing methods, nothing different there. I can access attributes that were defined in my base class for objects that were made from my derived class, which shouldn't be a surprise here. When I created my derived class, age was one of the attributes, so I can run this and you can see that it's going to pull age 22, which when I created, if you look back, when I created my student, I had age 22, so it's utilizing an inherited attribute. Okay, so I've done that. I can utilize methods from my parent class or base class for objects in my derived class. So those methods of the parent class are still accessible. So I can say my student1, which is an object of type student, dot age group. Age group is a method that was only available in my parent class. However, I can utilize it for objects from my student class. That's what inheritance does for me. So age of 22 would put this student in the adult age group. If you don't have an str function, that should say method, sorry. If you don't have an str method in your derived class, the one from the base class would have been utilized if you ran a print on the object. So if I do print my student1, you're going to see, because I didn't create my str on my subclass or my child class, I did create one of my subclass. So it utilized the one of my subclass. You can see it's got name, age, gender, major, and GPA. If I hadn't done this in my child class, it would have just given me name, age, and gender. In this case, what this is called method overriding, or polymorphism, which we'll get into more in topic 4. Next thing, so we got to continue testing. We got to keep getting better and better at testing, unit testing to be specific. So we can test this in very much the same way that we would test anything else for unit testing, object-oriented programming wise. I'm going to have to bop on up this view because there's too much on the screen here. So I'm going to switch out of here and then zoom in a bit here. Okay, so here is where I'm doing my testing on the 2 classes that you just saw me make. So just like before, I'm going to utilize the setup and teardown because this is a really good way to just create fake objects to test and then get rid of them so you don't end up having a mishmash of objects being created that aren't necessary. So first, import unit test as always. I'm doing my setup. Remember that it has to be exactly like this, lowercase s, uppercase p, or I'm sorry, uppercase u. And then this is the object that I'm going to create. So self.object name. The object type, so you can see I'm creating a person here, and then I'm doing the attributes for that person, and then I'm going to tear it down at the end. Again, recall that each time you run one of these groups of tests like this, it's going to first run setup, and then at the end of that group, it's going to run teardown. So for every one of these groups, I'm going to get a person 1, and then at the end of it is going to destroy person 1. It's very good to keep things clean. So first off, very typical, I'm going to test my object attributes to make sure that they are all working correctly. So I'm going to do a self-assert equal, ask it to give me self.person1.name. So it's self because it's within the context of my tests. Object name, and then the attribute is name, and I'm going to make sure that that equals fake, just like it should. You can see fake is what was up here when it was created. And then I'm going to do the same thing for age. I'm going to do the same thing for gender, just making sure all that works. And then continuing down, I'm going to then test the age group method to make sure my method is working. So I'm doing self.person2 equals person. So I'm creating another person here to do this. And then it's got these attributes. And then I'm going to assert that the method age group is over the hill for person 1. So you can see that I'm testing the case where it returns over the hill because person 1 is 99 years old. And then I'm going to assert that person 2 is a minor because you can see person 2 is 12. So in that way, I'm able to test multiple outputs. I'm creating 2 fake objects here so I can then test them both. Because the method has different returns depending on the age. And then I'm going to just make sure my str output is as I'd expect it to be. So I'm doing self-assert equal str self.person1, and then this is the text that should come out. So just making sure that that works. So that's one group of tests. That's testing my parent class or my base class. And now I'm doing, again, the same thing essentially on my child class. It makes it really good to have this kind of an outline structure so that each time you're testing a class and testing objects, you follow a very similar process. So you don't have to think as much about how to do all this. You know, you test the attributes, do that in one grouping. Test the methods, do that in another group or multiple groups depending on how many methods you have. Test your str outputs and your repr outputs in a separate group. So that way you just kind of have a good outline for how you should do it essentially every time. So again, set up and tear down, student 1, information, tear it down at the end, and then just go through again. Test the object attributes, test the methods, test the str. And I can run this. And you can see down here it ran all the tests and everything was fine. So now I know that my classes and objects are working as I expected to. Okay, so that's everything for testing. Now polymorphism, as I said earlier, method overriding is the other name for it. It's the ability to override the inheritance from a base class in a derived class. So by default, if it's not in the derived class, it will look up to the base class for things. So using our class from earlier, here's our person class. I haven't changed anything here. Again, all the same init, the same method here for age group, and the same str, nothing new. I want the age group method to do something different when it's in the student class, because a student might have a different age grouping here, and in fact here it does. So you can see this is my child class again, or my subclass. You can see that I've now added a method here for age group, because the age group for a student is totally different than an age group for a person. So you can see I've got, you know, if they're less than 18, they're what you would call an early entry student. If they're less than 23, generally, they'd be what you call a traditional student. And if they're more than that, they're going to probably be a non-traditional student, someone that's coming back to enhance their education, or maybe has a gap between high school and college or whatever. So somebody that falls into that third category. This is a different age group setup than just person, which was, you know, minor, adult, or old, right? So, and it's taking on the exact same name. And then I've got everything else is the same here. So I'm going to run this. And now I'm going to create an object, instantiate an object called student1. And now when I call student1.ageGroup, it's going to give me the method output from the child class instead of the method output from the parent class, because I am overriding that method. I am utilizing polymorphism to override stuff from the parent class within that specific child class. Okay, so that's polymorphism. Okay, last topic for today, multiple inheritance. This is where things can get a little more complicated. Multiple inheritance is when a derived class has two base classes. So UML of this, here's an example what we utilize. We've got a class of employee, we've got a class of person, and then we've got a class of student that inherits from both of these parent classes. And just looking at things here, you can see that both parent classes have an age group, right? Their employee has an age group, person has an age group. In this case, my student class does not have an age group. And then I've got employer, age, title. I've got name, age, and gender. So age is repeated in both of these. I've only got STR in my person class. I don't have it in my employee class. Okay, so just generally getting an idea of this because we're going to create all this now. So here's my new class that didn't exist before, class employee. So I've got, again, self, and then employer, age, title, and then self.employer equals employer. Same as always, nothing different here. And then I've got that method I'm creating where it's age group. And you can see self.age is less than 21 would be early years, less than 45 is middle years, and less than 65 would be senior level, and then retirement age if they're older than 65. Okay, so now I've created an employee class. And now I'm recreating my student class, and I'm going to inherit, you can see class student, I'm going to inherit from both the employee class and the person class. So I have to define that here. I have to state that this student class will inherit from these two superclasses. And then my init, as it was before, again, it has self, it has all of these attributes defined. And then I need to say where these attributes are coming from. So I'm going to say from person, remember we did super.init before? We can't do that here. We have to define which parent we're getting each one of these attributes from. So I'm saying from the person class, give me name, age, and gender attributes. And from the employee class, give me employer, age, and title. And then also add on major and GPA. So these are all the attributes that I want to have within my student class. So I'm going to run that. And now I'm going to create a student. And all of these attributes are part of my student object attributes. So name, age, gender, employer, GPA, I'm sorry, department. I don't remember exactly, but here we go. So I'm going to run that. So I've got all those attributes from my object. And now I'm going to access the age group method, which, as we saw in the UML, is defined in both base classes. So when I run this, it's going to give me the age group method from my employee class. Now, why it gave me that one instead of the one from my person class is an example of method resolution order. And it is a structured way that the programming language, or Python in this case, determines which one of the parents is going to look to first to find things. And you can see the resolution order for a class by using the .mro built-in method on the class. And there's two ways to say it. You can say student, which is the object name, or the class name, .mro, or you can say class name .dunders MRO. They both really result in the same thing. So you can see when I run this class is going to look in this order. It's first going to look in the student class, which is what you would expect. And then if it doesn't find it in the student class, it's then going to look into the employee class. And if it doesn't find it there, then it's going to look into the person class. And if it doesn't find it there, it will just look in the object itself. Okay, that's the order that has been determined. And you can see employee is first, person is second. If I go back to when I created my student class, you're going to see, a couple ways here, you're going to see that employee was the first one that I stated that it was inheriting from. So it's taking it in the same order that it is defined when I create my child class. Okay, that's everything I have for today. If you have any questions as you go through this stuff, please let me know. I'm available via email, and I try to be very quick to respond. Or you can utilize the help section in the weekly Blackboard module.